Hey folks, John Thompson, Spring Framework Guru here. So today I'm going to interview James Labocki from Red Hat. So James is a friend of mine. He works for Red Hat, and he's actually one of the product engineers over the OpenShift product. So OpenShift is a container orchestration platform. So it sits on top of Kubernetes, which manages Docker containers. And I'm pretty excited today to have the time with James to talk about Docker, even though in the course we're looking at just using Docker containers as kind of introductory to using Docker containers. This is going to give you some insight how Docker containers are used in the enterprise, why enterprises are going with Docker containers, what makes it so powerful. And James has some great insights not only into how Docker is being utilized, but how tools around Docker and how companies and enterprises are using Docker every day for their mission critical applications. So without further ado, I'm going to introduce James Labocki, and we're going to switch over to the interview I just did with him, and a lot of great content coming up for you. All right, folks, John Thompson here, Spring Framework Guru. I have James Labocki from Red Hat with me. So, James, can you tell me about your role at Red Hat, what you do there?
Yeah, so I'm the senior manager of product management in the integrated solutions business unit. So I work on basically the combination of our technologies from OpenShift, our container platform, to OpenStack, the infrastructure as a service, and cloud management technologies like CloudForms and Ansible.
Okay, that's quite the scope there. So the course I'm teaching is on Docker, and it's really for beginner level type people, and just getting them up to speed on Docker. So what are you seeing in the marketplace as far as adoption of Docker containers?
Yeah, so certainly there's a lot of hype if you go look out there about containers. Everybody wants to start containerizing their applications. So we're seeing pretty good adoption now. So we have our commercial offering for containers at Red Hat is called OpenShift. So that's basically what people would buy from us when they're looking to run their containers. And we're seeing very good traction in a number of industries, whether it's financial services, healthcare, and a bunch of other verticals. We're seeing quite a good uptake. Adoption starting similar to how you would imagine from the Unix to Linux move, or any kind of technology adoption curve. So you're seeing it move into development where people are kicking the tires, understanding what they want to do, and now it's eventually making its way into production right now in many of our customers.
Okay, so one of the problems I think Java folks are going to have is they're looking at a Docker container kind of being like a VM, and why do I want to run a JVM inside of a container and deploy stuff that way? So why are companies going that direction? Why containerize a JVM and run that out there?
Yes, I think when you look at traditional virtualization, what it did was it abstracted the operating system away from the hardware. So traditional virtualization really helped operations teams because they could separate the lifecycle of their hardware from their operating systems. So I could take maybe, like, let's say I'm running Red Hat Enterprise Linux. I could then take one version of Red Hat Enterprise Linux 6, and I could run it on whether it's VMware or our own KVM-based virtualization or Hyper-V. I could separate the OS from the hardware. So now I could refresh my hardware faster, and I don't necessarily need to refresh my operating system, so my applications don't need to change, and it creates a nice separation. What containers are providing is similar functionality, but at the application layer. So now my applications can be kind of almost decoupled and have their own life cycles away from my operating system. This doesn't mean that the certification of a running container to the operating system is important still, because there's still some ABI that needs to be maintained between things running in the container to the operating system running on below, and you need that tested and certified. But it does certainly mean that you'll be able to. It's basically allowing the developer and the operations teams to have a common format that they can pass between each other and not have to worry about the versions of the underlying operating system potentially.
Okay. Any security leaks in containers that we need to be worried about?
Yeah. So definitely, I think there are a lot of security ramifications of leveraging containers. One of the things that we're doing. So if you look at the history of containers, they're nothing new, right? They've been around since the late 70s, I think, with Chroot and Unix. So what Docker really brought to the table was it provided a common package format, so you can actually have an archive that everyone can understand, and then they also put APIs around it to basically make it easy to start and stop these archives, basically, of your application. Plus, it's basically used as like a union file system, right? So it kind of layers a bunch of file system changes when you do a build, and then it packages your binaries and libraries in there. So yeah, absolutely. One of the things you could imagine is if you could have dozens of VMs running on a physical host, you could have hundreds of containers running on a VM now. So that what that does is basically you have a propagation of potentially libraries and binaries with insecurities across those environments. So that's where tools that we have where you can actually scan containers, do container scanning, both during the build process as well as all the way out to production when they're running, and make sure that you don't have something with Heartbleed or another vulnerability in it running in production.
Okay. So how's that work? I mean, it seems kind of bizarre that you can run a few dozen VMs on a chunk of hardware versus hundreds of containers. I mean, why is that? Where's the efficiency at?
Yeah. So basically if you look at it, typically the way you split up a VM is the lowest amount of CPU you could give a virtual machine is a core. What's great is with Linux with namespaces in the Linux kernel and with technologies like C groups, which is control groups, it provides fine-grained resource control of your hardware even in a more granular fashion. So I could divvy up and do time sharing and split my CPU into 1,000 shares, and then take one core, split it up into 1,000 shares, and then hand 100 shares to one container, hand 50 to another, hand 30 to another. And that's all Linux namespaces and C groups taking care of that quality of service at the kernel level. So that's where we're able to actually do this and split this up into there.
Sounds like it's going to be challenging to troubleshoot performance stuff on this. I remember the days when you just needed VMstat and you're good to go.
Yeah, so that is absolutely another thing that we're working on pretty heavily, is instrumenting the kernel with the proper instrumentation, and then all the management tooling as well to help you do that.
Okay, so with the shared space and the shared memory, how does that work with the JVM? If I have a JVM running in two different containers, so I have two JVMs running, are they sharing memory at all for the execution of that, or?
So yeah, so there's multiple levels of memory sharing that could be happening, but primarily at this point they'd be sharing memory at the VM layer. So for example, if I have multiple copies of there's something called, for example, in KVM, there's something called kernel same page merging that would basically take multiple copies of memory that are the same and deduplicate them into memory to save a memory footprint. And that would happen based on however you set up the virtual machine and the hypervisor configuration in your virtualization. Okay. At the container layer, I don't believe we're doing that yet, where we're merging memory and footprint.
Okay, all right, cool. Because Spring applications are as many things, but memory efficient is not one of them.
Yeah, absolutely.
It does chew up some memory when you're running it in VMs.
We'll get your class to learn some Node soon.
Maybe not. Reactive in Spring 5.
All right.
Gets right up to Node. So in the course, I'm going to be teaching them the Fabricate plugin. And in my opinion, Fabricate seems to be the most capable plugin out there. There's a number of flavors out there, but as far as what I want to be doing in a Java lifecycle, as far as like building projects and being able to use Docker containers, not only build them and publish them, but I also want to use them in integration tests. Are there any other Maven or Gradle plugins I should be looking at, or is Fabricate like the one right now?
Yeah, so Fabricate certainly. So for those of you that don't know, so Fabricate is basically an upstream community that is actually run and sponsored by Red Hat, and there's a couple of engineers that were from the Fuse team that are actually working there now. And so, yeah, that's basically a microservices. Their goal is to build kind of an open source microservices platform. A lot of that work ends up going into OpenShift. So you're actually going to see a lot of those technologies basically running directly on OpenShift through the commercial platform. That's primarily where our investments are in there. I'm not aware of any others in the community side for Java developers. Not to say that there aren't. I'm sure Pivotals of the world and others might be developing things as well. But the one I'm aware of is definitely the Fabricate side.
Okay. Yeah, that definitely seemed to be the most robust out there. There's several options. I didn't even look at the Gradle ones, but I mean, Maven is the old workhorse for Java builds.
Yep.
So, and Fabricate seemed to have a clear lead in the space. So you mentioned OpenShift, and so help us make the leap here from running a little web server in a Docker container on a Linux host to what is this thing called OpenShift?
Yeah, so essentially OpenShift is our container platform. So when you want to start running containers at scale, it's pretty simple to run. Build a Docker file on your machine locally and run it. But when you actually want to start scaling that to multi-container applications and then scaling them globally, that's where OpenShift comes in. And so OpenShift is based on it provides both Red Hat Enterprise Linux, the Docker runtime, and also provides Kubernetes. So Kubernetes is a project that was initially started by Google. So the folks behind, if you don't know, every time you log into Gmail, for example, that's actually running in a container. So Google stops and starts billions of containers a day. They're probably the largest scale container deployment that we know of. And so when they started a container orchestration project, we definitely jumped all in and partnered with them on that. And so so basically what OpenShift provides you is the Kubernetes platform, which allows you to orchestrate container deployments. So if you want to deploy, it basically has a concept of something called a pod, and then that and services and routes, so you can actually expose a route externally about your multi-container application to the world. You can do things like upgrade your containers and have a lifecycle around them, so that when they move into production, you can do rolling upgrades and all those pieces, as well as a bunch of capabilities around taking your source code and actually building an image automatically through there, whether that's plugging into an existing pipeline or leveraging our own source to image capabilities in there for building images.
Tell me a little bit more about the source to image. How does that work with Java?
Yeah, so there's a number of different patterns. So one of the containers so when you deploy OpenShift, you have a number of applications you could launch out of the bag, right out of the box, and one of them is a Jenkins image, so you can actually deploy Jenkins inside there and leverage that. There's another, basically, we provide a number of pre-built images in a registry so that are source to image ready. So you can literally put your GitHub repo when you're launching your new application, provide your GitHub repo, and we will take the source code from that GitHub repo. We will run basically a Docker build and build that image and then put it in the registry and then also launch it for you. And you can go directly to your running application, and then every commit you make to your registry, you can actually build a hook to actually go ahead and kick off a new build every time.
So sweet. So I can just check in, and then it'll go through and automatically deploy new Docker containers to my target environment.
Exactly. And we actually have a container development kit. So there's a bunch of flavors of OpenShift. One of them is OpenShift Online. So you can literally go to openshift.redhat.com. That's a hosted service that we run. You can go launch a couple of containers for free on there, or a couple of apps for free. I forget what the limit is, and get started. If you want to actually run it on your workstation, you could download our container development kit, CDK. Just look up Red Hat Container CDK, and that'll give you a pre-built VM with OpenShift on it and ready to go out of the box.
Okay, cool. So I am running out of questions. So is there any other things that you can think about that'd be interested to a Java developer in the Docker world, or even OpenShift?
Yeah, I think just one last thing to note is one of the things that we're seeing a big uptake on is basically Ansible from an automation standpoint. So a lot of people, a lot of our end users are not wanting to buy into a single way of doing things, or they want an automation language that's familiar between both development and operations. So we're seeing a big uptake there. And Ansible Container is a project that we have that allows you to, if you're familiar with Ansible playbooks, I'm not sure if any of your audience would be, but if they are familiar with it, they could literally take their same skills of authoring Ansible playbooks, and those can generate Docker images for them, and that gives them a clean path to running in Kubernetes as well.
Okay, so the Ansible container, is that the same thing as a Docker container, or is that different?
The Ansible container is basically just a way of taking Ansible playbooks and creating Docker containers from those Ansible playbooks in a structured fashion.
Okay.
It's not a competing image format or anything like that.
All right, cool.
Yeah.
All right, James. I'd like to thank you for your time today. Definitely appreciate you taking the time to talk about Docker and all the offerings of Red Hat around it. So a lot of exciting stuff going on.
Yeah, cool. Thanks for the time, and best of luck to your class.
All right. Thanks, James. Cheers. Okay, that was a really cool interview with James. Really glad he took the time to talk to us about that. So one of the things that James got into was using OpenShift and Kubernetes. Now, that's something we haven't talked about in the course. And I worked with a client last year, and we did a lot of OpenShift and Kubernetes, and we're deploying Spring Boot in Docker containers under Kubernetes. And one of the cool capabilities, you've heard of these things called microservices, which is like the latest buzzword, and people are arguing about how big a microservice should be, yada, yada, yada. But let's say we do have a microservice. Let's say it's for a product lookup. If we want to look up products and get product information, have a microservice for that. One of the things that we can do with a product like Kubernetes, and it's important to point out that OpenShift is a enterprise management tool set kind of built around Kubernetes. So Kubernetes is like the engine, and that's what was developed and released by Google. Google runs, as James pointed out, Gmail using Kubernetes containers managed, or Docker containers managed by Kubernetes. So going back to the microservice example, one of the neat things that we can do is if I have my product microservice, like a product lookup microservice, in OpenShift/Kubernetes, I can say I want 5 instances of the product service running at all times. And Kubernetes is going to manage that. So if one of those instances becomes sick for whatever reason and dies, it'll automatically spool one up. Another interesting capability is we can do dynamic auto scaling. So if we say our instances are starting to become hot, and they're running at 70% CPU utilization, we will auto scale and bring up additional instances to spread out that load. So OpenShift is going to give us a virtual load balancer for that microservice and spread out the load. So this is one of the cool parts about it. So a lot of the focus of the course is on just going through and using Docker containers for Java development. But if we're building out microservices and deploying it, Docker is absolutely a very relevant technology when you start pairing it with container orchestration frameworks such as Kubernetes. So a lot of cool stuff that we can do there. James is a great resource, and I didn't want to get down the rabbit hole on a lot of the OpenShift Kubernetes stuff because that's outside of the scope of this course. I could totally do a course just on Kubernetes and probably still not touch on everything. So I want to keep this course focused on Docker for Java, but at the same time have a resource like James to show you the broader use of Docker in the enterprise and why it's becoming such a popular technology. So really hope you enjoyed this interview. James is a great friend, one of the smartest guys I know, and knows a ton about Linux and Docker and stuff. So really glad he was able to do this for us.